Okay, this is it, guys. We have learned how to name everything that we need to name in this class, which is so important because now we have so many different compounds that we can use in writing our own chemical reactions. I know this is a lot. I've given you ionic, and that is just a lot going on. I have given you covalent. That's not quite as much going on, but there's still something going on there. And I have even introduced acid nomenclature. So we got 3 things here to remember how we name and write formulas for. And y'all, on our nomenclature booklet, I forgot to mention here are our rules for my acids. Yeah? It tells you that hydrogen plus a single element or a polyatomic ion without oxygen, you go hydroic acid. Hydrogen plus a polyatomic ion that ends in 8, you go ic acid. And then hydrogen with a polyatomic ion with oxygen that ends in ite goes to us acid. Okay, so that's here for you guys to use. Lots of great stuff on here on the back of our foldable and specifically inside of our doors for ionic and covalent. The most important suggestion I could possibly give to you. You look at this page and you were like, absolutely not. This makes me want to throw up. No, you are going to want to classify each one of these in terms of whether it is ionic, covalent, or an acid. And after you have done that, then you can use your brain to only tackle one type of each type. So what am I looking for to tell me what I got here? I always like to look for my acids first. My acids come in hot with a hydrogen in the front. Do you see any hydrogens in the front? Woo! Right there. So he is an acid, right? Because he is a hydrogen. Any more hydrogens come in the front? Way down here on number 19. Number 19. Whew! Acid. Oh my goodness. How am I going to pick out the acids on the names? Y'all, it's literally going to say acid at the end. So that's good for us. Acid. Acid, 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 acid. Cool. Okay, not that many acids here on the first page. That means everything else is going to be ionic or covalent. Once again, your ionic compounds are a metal and a nonmetal. Cation and an anion. Your covalent are all nonmetal. So I'm looking at this and I got my red and my blue ready to go and I'm feeling good about myself, right? So for this first one, I'm like, okay, chlorine is a nonmetal. Oxygen is also a nonmetal. He is covalent. Yes? Carbon is a nonmetal. Sulfur is a nonmetal. Also covalent. I hit this one in right now. It is magnesium. Magnesium is a metal. I don't even have to look at the second guy because we always know if we got a metal coming in first, it will be an ionic compound. Okay? Silicon is a nonmetal. Fluorine is a nonmetal, right? So that is covalent. Okay? I have got arsenic. Arsenic. I know he sounds kind of like he's going to be a metal. I always have to check. He's not. He's a nonmetal. I know. I almost messed that one up too. I'm like, no way, that weird name. He is not something weird going on there. He is just a nonmetal. Then we got iron. So you guys, y'all can feel free to do this. Do not be freaked out about your polyatomics, right? So if you have a list coming down here of ICs and A's, then you can switch your brain and be like, okay, acids, I'm going to tackle you. I'm going to tackle you, okay? And then covalent, or whatever order you want to do. Do not put Greek prefixes, mono, dis, tris, tetras, or any ionic compounds. No, 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 no. Okay? For my ionic compounds and for my acids, we know parentheses around polyatomics are super important. Oh my gosh, let's see if we have any polyatomics in my acids or in my ionic compounds that could benefit from some parentheses. KOH, we know potassium is a metal, so this is ionic, right? Ooh, here's another ionic with potassium, and this time permanganate. Okay, I know I did not make the whole list. I really went on this mixed practice page to kind of roughly just get you guys started and let y'all go off to the races and mostly just check your work on my answer. Keep it. I thought I would give the suggestions of doing the ICAs and then your parentheses around your polyatomics to ground you, because there are always only 2 things in these compounds, whether they are acids, ionics, or covalents. Now over here on the naming thing, same thing. I'm going to be looking for acid to tell me if it's an acid, but then I'm also going to be looking for that first guy if it's a metal or a nonmetal. Chlorine, nonmetal. Oxide, oxygen, so he is covalent. Silicon, a nonmetal. Fluorine, a nonmetal, also covalent. Bromine, a nonmetal. Dicarbide. It's carbon. A nonmetal. Covalent. Copper. Here we go. A metal. And then phosphate is a negatively 3 charged polyatomic. Okay, so I've got my first ionic here. So what I'm looking at here is that first guy a metal? And if he is, he totally is an ionic compound. Another thing I can look for in these names is if you see prefixes. We only use these prefixes for my covalents. So that's another good red flag. Another thing I can also look for is, if you see a Roman numeral, we know we only use those for metals, which means that that will be an ionic compound. So for my ionics, we crisscross, right? For my covalents, we use those prefixes. I am going to let for you guys to use your booklet, use your brains, and start tackling this page. I think it's going to be a lot of fun, honestly. Well, a lot of fun. I do think it's going to be a lot of fun. It will be worth your time doing this up front. Okay, and there is a back page because I believe in a lot of practice, and this practice is so important because we are going to need to be able to write these formulas and name things for next unit when we use these guys to write our own chemical reactions, which is going to be super cool.